are going to discuss the building motion. Building motion is a very important one in the speed frame or roving frame, whatever you say. The functions are that to shift the belt on the cone drums. See, cone drum is a variable speed drive for the machine. We need it because we have to continuously vary the speed of the bobbin, and hence this is basically a variable speed drive. So, the cone drums, on the cone drum there is a belt which is running, and you have to keep shifting the belt on the cone drum. So, who is going to shift? So, you must, there has to be a separate mechanism which will shift the belt, not only that shifting, but at what time we have to shift it. At a specified time we have to shift the belt, we cannot shift the belt arbitrarily at any point of time. So, that has to be controlled by some other mechanism or by some other sources, and that is what building motion is going to do. It is going to shift the belt at a specified time by a specified amount. Next is shortening of the lift. The way the bobbin is built, that is this, that you have to have much steps. We must remember that the roving bobbin is conical at the top and at the bottom. That basically means that the lift of the bobbin rail will keep on changing as we keep on laying the layers. The very first layer is over the longest length, and the subsequent layers will be laid on a shorter length gradually. So, this shifting, the lifting part has to be shortened as we keep laying the layers. The other thing is to reverse the direction of the traverse of the bobbin rail. The bobbin rail moves up and moves down continuously throughout the bobbin building. So, whenever it has reached the topmost position or the bottommost position, we have to change the direction of the traverse. This is also the job of the building motion, that it will be able to suddenly change the direction of the traverse as soon as the rail has arrived either at the topmost or at the bottommost positions. These are the three important functions of the building motion. Now, first of all, we are going to discuss the cone belt shift mechanism. Now, if you look at the diagram on the right hand side, then you will see that there are two brackets. If you see the bracket 7, this bracket and bracket 3. Now, this bracket is attached to the bobbin rail, which is moving up and down. So, changeover mechanism consists of metal brackets 3, 7, and the other things are two inclined rods which are numbered 5 and 6. This one, this rod 5 is here and 6 is here. Two rods are there, inclined rods are there. So, these two rods and the brackets are also there. There is another one important thing which is here, that is there is a micro switch, which you can see here, there is a micro switch overall there also. So, the brackets, the inclined rod, and there is a micro switch which are there. The rods are inclined at a certain angle. So, these are secured to the bobbin rail and moves up and down with the rail continuously. A stationary pin which is shown here, stationary pin is pressed by one of the rods during upward stroke and by the other during downward stroke, and as soon as it is pressed, it generates a pulse by the micro switch. So, once this is pressed, a pulse is generated in the micro switch, and it also actuates the pneumatic servo cylinder. The servo cylinder moves the ratchet lever over the ratchet wheel by half tooth. We will see in the next diagram that as a result of this pressing, what happens that a ratchet lever and the ratchet wheel is going to turn by half tooth. We will see in the next diagram how it is causing a ratchet wheel to turn. Each pulse triggers a release mechanism to permit rotation of the ratchet wheel by half tooth. Now, as soon as this micro switch is pressed by the inclined rod, the action starts. So, what is happening due to this? If you look at this diagram now, let me explain this diagram now. The ratchet wheel is here as shown, and the ratchet wheel over the ratchet wheel, or the same ratchet wheel is also shown in the lower diagram here. Now, the ratchet wheel is connected to a mechanism as shown it there. If you look at this drive very carefully, there is a wire going and it is connected to a belt guide, and then there is inclined plane. It is also connected by another string or rope, and then there is a dead weight which is hanging from the other end. Now, the point is that this dead weight is always trying to pull the ratchet, is not pulling the ratchet wheel. The ratchet wheel in turn is connected, there is a little small eccentric or cam over there, and it is connected to the cam, and cam and ratchet wheel are basically sitting on the same axle. So, as soon as the pull that is exerted by the dead weight is always trying to turn the ratchet wheel. The constant pull is always there, it is trying to always turn the ratchet wheel, but the ratchet wheel is not in a position to turn because there are two poles which are there, as I shown in the diagram here and here. These poles are not allowing the ratchet wheel to turn, it is coming on its way. And if we look at these two poles, you will find in this case the left hand pole is engaging the tooth of the ratchet, and therefore, as long as it is engaging, the ratchet can't turn, even though there is a turning moment of it because of this dead weight that is acting on it. The other side of the pole, the right hand side pole, is in disengaged position. It is away from the tooth and not having any effect. So, there are two poles, on the one on the left hand side and the other on the right hand side. Now, what happens that whenever the micro switch is pressed, this pole is going to be disengaged. Momentarily it will be disengaged. As soon as this is disengaged, suppose in this case left hand pole is disengaged, right hand pole will immediately come on its way and will not allow the ratchet to turn fully. So, during this process of disengagement and engagement, the ratchet wheel turns by half tooth. That is, it is the left hand pole will disengage, the ratchet will be free, it is about to turn, it turns by half a tooth, and by that time the right hand pole comes on its way and engage with the tooth of the ratchet, and therefore, is not allowed to turn beyond half a tooth. So, this engaging and disengaging of the pole is actually triggered by the pressing of the micro switch, which is fixed on the bracket, and this gets only pressed when by the time the inclined rod is coming on its way and pressing it. Either there are two rods we have seen, the top rod or the bottom rod, one of the rods is coming on its way and pressing it. Whenever this is pressed, this thing is going to happen. And therefore, what happens, as soon as the ratchet turns by half a tooth, on the other side of the ratchet, which is not shown here, you will find that this is the ratchet, and then the ratchet is connected through a set of gears by the gear. See here, ratchet change wheel is there, 86 teeth gear is there, another 86 tooth gear, and then there is a another wheel on which this cam or eccentric is mounted, which is not, this is mounted. This is also shown here. This is nothing but, so rotation of the ratchet will cause the cam on which the belt rope is attached to turn by certain degree. As the ratchet turns by half a tooth, we can find out what much will be the degree of rotation of the cam, which is shown here. This is the cam here. So, as a result, as the cam turns by few degree, the cam is connected by wire rope to the belt guide, and hence the belt guide will move towards the right hand side and shift the belt. So, what is happening is that at a certain point of time, the ratchet is disengaged from its ball. During that little time, duration of time, it turns by half a tooth, and this half tooth movement of the ratchet is translated into few degree of movement of the cam, and the cam, therefore, as soon as it turns, the belt guide is going to move to the right hand side and therefore shift the belt on the cone drum. That is how the mechanism is going to work. Amount of belt width is controlled by the ratchet change wheel, which is shown here in the lower diagram. If the ratchet turns by half a tooth, by how many degree the cam is going to turn will depend upon the set of gears which are in between the ratchet and the cam. So, if I change the gears in between them, if I change the number of teeth of those gears, I will be able to control the rotational movement of the cam for a fixed degree of movement of the ratchet. Ratchet will always turn by half a tooth, but the cam movement or cam rotation can be changed by the set of gears which are in between the cam and the ratchet. So, by ratchet change wheel, which is shown here as 30 tooth, this can be 29, 28, 31, 32, depending upon the number of tooth, the rotation of the cam can be changed, and that way the belt will be shifted on the cone drum, and this belt shifting, therefore, because the cam is there, the belt shifting will be not always by equal amount, because the rope is or string is passing over the cam. So, for the same degree of rotation of the cam, the amount of belt shift is going to be different, and that we need, because the cone drums are not really hyperbolic. In the most of the modern machines, they are straight cones. As we have learned earlier, that hyperbolic, had it been hyperbolic cone, we would not have needed the cam at all. But because we have straight face cone, straight surface cone, therefore, we need a cam, because the belt has to be shifted in a non-linear manner, not in a linear manner, and that is why the cam is there today. So, this is one job that we need to do, and this is all triggered by the pressing of the micro switch by the inclined rods, one in the upward stroke and the other in the downward stroke. Next thing comes is the reversal of the bobbin rail movement. How it is accomplished? It is accomplished by shifting rod which can rotate as well as can shift laterally. So, in this diagram this shifting rod is shown here, no, shifting rod is shown here. This is the shifting rod, this is the shifting rod. Shifting rod is shown here. So, shifting rod can shift laterally. At the same time, it is always rotating in a given direction. Shifting rod rotating as well as it can shift, it has a lateral movement. Reversing originates from the reversing bevel gear. If you look at the shifting rod, you see that there are two bevel gears on the one on the right hand side and left hand side. So, the bevel gears are basically 1 and 2, and this is going to engage another bevel gear which is 3, which is mounted on the vertical shaft, and this vertical shaft in turn is connected to two wheels, and from one of those wheels there is a lifting chain which is connected to the bobbin rail. So, what happens at the mechanism is, as the shifting rod, which is always anyway there, it is rotating, as it turns, the motion is transferred from gear 2 to gear 3, and therefore, the shaft is rotating, and as rotation of the shaft will cause the chain to either wind or unwind, and therefore, it will move the bobbin rail up or down. How it is up and down? When the bevel wheel 2 engages with 3, the shaft will rotate in one direction. But what happens that if the shaft is moved laterally in this direction on the right hand side, then wheel 1 will come into contact with wheel 3, and therefore, the rotation of the shaft will change in the opposite direction. So, depending upon whether bevel gear 1 or 2 is engaging the gear 3, the lifting chain will be either wound or it will be released from the sprocket wheel, and the lifting chain in turn is connected to the bobbin rail, and therefore, it will cause the bobbin rail either to move up or to move down. Now, what it is that shifts? The shifting rod. That is what is done by the right hand side chamber that you see it here in this diagram. The right hand chamber, there is a pressurized air, or general pressurized air to be there, or it could be some other liquid could be also possible, and there is a cylinder over here. So, whenever the micro switch will trigger the motion that the bobbin rail has reached the top point, then only the micro switch will be pressed, or when the rail has gone to the bottommost position, the micro switch will be pressed. Now, whenever this is pressed, it is not only shifting the belt, it is also causing pressure to increase on the left hand side of the chamber or on the right hand side of the chamber, and thereby also it is shifting the rod at the same time. By if I increase the pressure on the left hand side of the chamber, the rod will move on the right hand side, and therefore, in that case gear 1 will come into engagement with gear 3, and hence the rail will move in one direction. In the other case, the pressure will be there on the right hand side of the chamber, and therefore, the piston will move on the left hand side, and hence the rod will also move the left hand side. In that case, gear 2 will come into contact with the gear 3, and therefore, the reverse movement will start. So, the bobbin rail will move up and down due to this mechanism, and this is all triggered by the pressing of the micro switch by the inclined rods which are there, which are placed over there. Now, next thing that comes is the shortening of the lift. We have to keep on shortening the lift. You see that otherwise the conical shape will not be able to produce on the top and the bottom. And why do you need conical shape? That also we have discussed earlier, so that the build of the bobbin remains strong and stable. If we do not have a conical shape, from the edge the coils will simply slough off, they will slide off, and hence therefore, we need a conical edge. The inclination of the rods 5 and 6 here, as we have shown earlier, are adjustable and correspond exactly to the taper of the bobbin. The taper of the bobbin, whatever is the angle alpha, if you look at this, the angle alpha and the inclination angle of these rods are also exactly alpha. They should always also match. So, whatever alpha is here in the inclined point, or same inclination will be there in the final bobbin also. Ratchet wheel is rotated by half a tooth at every changeover, and the micro switch 4 is shifted by a small amount. What happens? That the micro switch itself moves by a small amount to the right hand side as well, and if it shifts on the right hand side, every time it is pressed, the rods will engage the micro switch early during the lift of the stroke, and thus changeover will take place correspondingly earlier. So, whenever the micro switch is pressed, as a result of that many things are happening actually. The belt is shifting on the cone drum, the bevel gear is shifting, and one of them is engaging the particle shaft. At the same time, the micro switch itself also, this assembly is moving on the right hand side. So, this is moving on the right hand side, this micro switch part only, and therefore, because the rod is inclined, next time in the next upward stroke or downward stroke, it is going to be pressed little early because of the inclination of the rod. The rods will engage micro switch early during lift, and it will take place little earlier. Thus, continuous reduction in the lift will take place, and bobbin ends becomes tapered as well. So, this is how the lift is shortened. Now, we will discuss about the something about the drive part also. Let us say first, let us discuss about the flyer drive. In this diagram, we have a flyer drive, which is this flyer receiving drive from the top. Flyer has to run at a constant speed, since twist has to be kept constant. So, bobbin speed is variable, but flyer speed is constant. Hence, drive to flyer should have a constant source of speed. Flyer speed change wheel should not affect the speed of any other element, therefore, because rest of the elements speed are connected to the speed of the bobbin as well. So, flyer speed should be, if I want to change the flyer speed, we have to show that it has a constant source of drive, and if I want to change it, it should not change the speed of other things, other working elements. In this diagram, see, there are two ways this flyers are turned. Sometimes the drive is given from the top, in some machine manufacturers this is there, in some machine, with some machine manufacturers it is given from the bottom also. So, both types of drives are there. Flow of motion to the flyer, if we try to understand here, then you look at this, follow the arrow, we will see how the motion is going. In a typical case, we are showing it here, how the motion is going from motor to the flyer. The path is shown by this red arrows, motor pulley to the central shaft. Central shaft is going to the other extreme end, from there it is going down, from there it is going at the bottom, and then it is driving from the bottom, this here it is driving the spindle on which the flyer is mounted. So, this is a drive, the drive is given from the bottom. The other drive that we give is drive to the drafting rollers. Let us try to understand how the drive is given. Drive comes to the front roller first. If we see from the, if I try to trace the path of motion flow from the previous diagram, or we can take the gearing diagram of any machine and look at it, we will find that from the motor to the central shaft, the drive is ultimately reaching the front roller first, and from the front roller the drive is distributed. As you see here, it goes from here, again the red arrows are actually pointing out how the motion is flowing from front roller to set of gears, to the middle roller and to the back rollers. That is how it is shown here. The other important motion flow is about the bobbin, also is also shown in this diagram. If you try to trace the path of the motion to the bobbin, then you see that this path is little complicated. It is from motor, first of all it goes from here to the pulley, which is the basically central shaft, and then from there it goes straight to the top cone drum. You see here that there is a top cone drum, we have given the motion here. On the top cone drum, the motion is coming back from top to bottom cone drum, from bottom cone drum is goes and it goes to this particular gear. So, the variable speed is going over there, and then from here it is going to the differential gearbox, differential drive. So, differential box also gets a drive from the main shaft. The main shaft is connected to the differential gearbox. So, therefore, this constant drive that comes from the motor to the differential gearbox and the variable speed which is coming being fed to this gear number 50, through that the output is going to this gear. From here through these red arrows, it is actually going to the bobbin. So, this is the motion transmission path from motor to the final bobbin. So, the bobbin is receiving two motions, as you all know. One, a constant motion generated by the motor pulley and the pulley mounted on the central shaft, which is turning the differential gearbox as a whole, and the other input to the differential is coming through the bottom cone drum, between the two cone drum, top to bottom. From bottom it is being fed, and then the resultant output, you see, look at this shaft, if you carefully see that the shaft is actually loose on the central shaft, and from there the output is being fed to the bobbin. This is how the drive is given to the bobbin. Okay, with this we are closing this session. Thank you.